licensed amateur since 2002. This whole balloon thing was the main reason that I got my license, and I'll talk a little bit about that in just a little while. We'll get to the Pico balloons. We'll kind of do a little precursor to that, but let's see. Education. I graduated from high school in a little town of Clay Center, Nebraska. Went to college at Southeast Community College, got my associate's degree in electrical, and I have currently spent almost the last 30 years as either an instrument technician or a systems technician at our local power plant. So always been around things, kind of electrical, electronics. I've always had a big curiosity in electronics. I probably chose the wrong career path, but it's worked out for me. Anyway, that's kind of me. My good friend, Roger Franzen, I'll let him kind of give you his little 2 cents on his background and himself, and then we'll get going with the presentation.
Hi guys, I'm Roger Franzen. I also worked at the utilities department, the same power plant that Roger did, and I was kind of a late bloomer. I ended up going back to college, got an electrical engineering degree in the early 90s, and Roger happened to be my replacement at the plant. And so I hadn't met him until I came back and worked Christmas vacation at the plant. And within like 10 minutes, we were cracking jokes and talking about, movie quotes and stuff that we liked, and we've been friends ever since. Roger got me interested in, he was pretty instrumental in me getting my ham radio license in 2014. And he approached me, and I've done some of his high altitude balloon projects, helped with him. And he approached me about doing this Pico balloon thing, and I jumped at the chance, and it's been quite a ride. So I think we'll let Roger start his presentation, and we'll go from there. Glad to see everybody.
All right. Thanks, Raj. Well, let me see if I can get Mr. PowerPoint fired up here. And all right. We'll get okay. That's not the screen I want. All this technology and I can't share a simple screen. Okay. I think we're good to go here. And if I give this a go. All right. I think I got this up. All right. We'll get started here. The R squared engineering thing that we're calling our little hobby group kind of came about because of being joined at the hip as we were working at the power plant. It was always, well, why don't we get Roger and Roger, or Roger squared as they started calling us. So we sort of decided to call the little hobby thing that we were doing R squared engineering. We went through the introductions and our background, and let's get going with the meat of the project here. All right, you guys are right in my notes here, so I'll move you over. All right, as I said earlier, the sole reason I got my amateur radio license, working at the power plant, around technical people, one of the guys I work with saw an article on the internet about some folks from Michigan that were launching weather balloons with their own DIY payloads attached. And I thought, well, that sounds kind of cool, because they were able to track their payloads through the entire flight using amateur radio frequencies and modes. Well, this kind of intrigued me. I knew a little bit about amateur radio at the time. Growing up in a small town, there was a handful of hams in our town. And I just remember seeing, the big towers and the big antennas, and they all had, the funny looking license plates with the obscure 0 on it. And anyway, so I started doing a little research, and got interested. I hooked up actually, I think with one of your members or former members, Mark Connor in 9XTN, was kind of my weather balloon, the latex balloon mentor. So Mark was kind of instrumental in helping me get through the first flight, and we've kind of been good friends ever since. We don't see each other a lot, but we communicate quite a bit via email and Twitter. So anyway, with a little assistance from some friends and some hams here in town, I successfully launched and recovered 11 flights, and that doesn't seem like a lot, but it was a lot of fun. We got a chance to build some things, fly some things into the stratosphere, and it kind of got expensive, so we kind of moved on. And
Hey, Raj, can I make one comment?
absolutely.
That was me back there laying on the ground using my fat body to keep the balloon from flying away.
Well, somebody's got to do it, right? One of the fun things about the latex balloon flights was the first thing that you wanted to do when you got home was to see what kind of pictures and video you had, because you don't typically get to see these kinds of views, you know, from the ground. So this particular picture, I had a poster size made of it, not quite a poster, but a little smaller. This is looking north east, and Lincoln is down there in the bottom center. If you look real hard, you can probably see the 12,000 foot runway, and then you see there's a little trail, or what looks like almost a straight cloud down there. Well, that's a jet contrail from up above. So you're kind of looking down, because we were about 90,000 feet when this picture was taken. Let's see. No balloon presentation would be complete without a tiny bit of history. This is the guy that started it all back in like 1987. Mr. Bill Brown, WBAELK. He is a NASA electrical engineer. Super nice guy. I think he launched his first balloon from his father's farm down in Huntsville, Alabama. And since then, he's launched over 600 balloon flights, including the Pico balloon flights. And he was actually one of the first people I heard about doing this. And this was probably 10 or 12 years ago. Bill has designed his own Pico tracker. It's called the Sky Tracker, and it's one of the few that is available for purchase. Next slide. The reason I wanted to get into Pico balloons was, first of all, latex ballooning was getting very expensive. It was costing anywhere from, at the time that I gave it up, it was probably over $100 for a balloon. Helium was getting increasingly hard to find, but helium was super expensive at that time. A cylinder of about, I think we were using close to 300 cubic feet. It used to be that you could get a cylinder like that for about 80 or 90 bucks. And I think at the time that I quit, it was about 300 and something. I checked when we got into the Pico ballooning, and they won't even sell helium unless you're a regular customer or, medical or science. There's like, a handful of people that get to buy the big quantities of helium. And I think a lot of it's for like, I'm trying to think of the MRI machines and those kinds of things. But anyway, so a typical flight, we would have $100 and some for a balloon. We'd have around $100 for helium. Typically we use lithium batteries because alkalines don't handle the cold. That was another, probably $20 in disposable batteries. And then, of course, the gasoline to chase the balloon. And occasionally, like on the last time, the radiator cap protects itself and allows my radiator to blow a hole in it. So we were about 20 miles south of Beatrice, I think, or somewhere down in that neck of the woods when this happened. We did find the payloads and got everything retrieved just in time to have the Jeep towed to the local dealership, and then Raj's wife come down and pick us up so that we could get back to Grand Island. So Um, let me see. So why a Pico, or what is a Pico tracker? Well, it's a small, super lightweight, always under an ounce. Ours is just over a half an ounce. It's got a GPS receiver on it. In this case, it's a GNSS and GPS, so it'll do not only the US's GPS constellation, but it will also do the Russian. I forget what they're called. I think it's GLONASS, and the Chinese Beidou. So any of those satellites, this one is able to pick up. So it gives us a little better chance of maintaining a lock once we get one. It's a small amateur radio transmitter, and it is, of course, solar powered because batteries are really heavy and there's no easy way to charge them other than the solar. And well, we can do that to a super cap, and we just kind of shut down at night and only transmit during the day. So you might ask, why design and build your own Pico tracker? Well, the reason for doing so is it's challenges, but there's probably, I think, 3 or 4 different groups. Bill Brown is one of them that do sell. They either sell their trackers or they offer their designs for free. When I got the idea to do this, I really wanted to do my own, just to say that, you know, we accomplished this, and just kind of a matter of pride. And like I said, of course, challenges, because, well, who doesn't like a good challenge? And we had plenty of them. I think we still have more to go. Raj had stuck some notes in here that and the challenges we've had. It's like we went up against the whole chip shortage thing. We went through counterfeit chips and wondering if they were doing what they should. You know, even though they were counterfeit, we were hoping that they were the same, would provide the same functions as something that was made here in the US. Design errors, things that we forgot, difficulties using other programmers' libraries. We use the Arduino programming environment, the IDE, and because a lot of these different chips and circuits use somebody else's library to support it, which means, you know, it's a bunch of code that's already been written specific for this so that we don't have to. And that's all great, but lots of times there's not really good documentation on this stuff. And we've even found mistakes. You know, we're all humans. And of course, neither Raj nor myself are programmers by trade or experience. We just kind of hack our way through this stuff. And through the last, well, we started this in February. Raj has actually gotten pretty good at sorting through some of the code and figuring out where our shortcomings or others are. There's a whole new thing. You know, being a ham radio operator is one thing. Knowing what RF is and how to deal with it, and designing a circuit board that is actually going to be a transmitter is quite another thing. And we kind of found that out the hard way. Anyway, in designing this thing, so we were going to have GPS because we need to know where it's at. It was going to be a low-powered amateur radio transmitter. There are 2 modes that are kind of the ones that the Pico guys like, and that is APRS, of course, and Whisper. We opted for APRS mainly because I was most familiar with that from doing the latex balloon flights, and we were kind of hoping that that would be the easier of the 2. We're going to find out about that. So let's see, we talked about APRS. There are quite a bit of differences when you're talking about the latex balloon flights, because I could grab a low power HT. There was some commercially available encoders that you could connect to it. And then, you know, you stuff all this in an insulated lunchbox and you tie it to a big balloon that's got all kinds of lifting power, and you send it up. So it wasn't really rocket science. Neither is what we're doing with the Pico balloons, but oh my, has it opened our eyes as to what this whole RF thing is about, because we needed to build something from scratch that could serve the same purpose, yet be solar powered and weigh less than an ounce. So Raj and I decided on the APRS, and I got to tell you real quick, originally this was going to be a solo project. I was going to do this myself, and I got into the research part of it and realized what I was up against. And one day I was having lunch with Raj, and I said, "Hey, Raj, how would you like to help me out with a little project?" And I explained it to him, and he said, "Well, I'd have been disappointed if you wouldn't ask." So, and I am so glad I did, because I wouldn't probably be a fourth of the way through this if it wasn't for the time and the research that he's put into this. So my hat's off to my friend here. Anyway, moving along. So we decided, I guess we have to learn how to build a transmitter. Well, first of all, the component sizes that we were working with was all the surface mount technology, and all of the cool chips and all of the latest stuff that's available seems to only be available in surface mount. You know, we were from the old school days of repairing electronics, you know, with the through hole components. You know, the legs, you poke through the holes, you get the big soldering iron out. It's not that, you know, not that difficult. This stuff's tiny, and I have no idea whose idea it was to put pads on the bottom of a component that don't stick through a board. This is the chip that you're seeing on this dime is the SI 5351 chip. That it's a clock generator chip that we use, that is essentially our transmitter. It's a configurable, programmable clock generator that can produce, you know, the VHF frequencies that, like for APRS. And just getting that to work correctly was a bit of a challenge.
If I can add something too, Raj, this particular chip, or this particular model, a B model of this chip, also had an analog input that you could use for FM modulation. And so we chose this particular chip because it lended itself really well for the methods that we were going to use for transmission.
Yep. And this was one of the chips that we were having a hard time obtaining. We bought some, you know, through the Chinese places, the AliExpress, got some off of eBay. I even had to, I had to buy some like $25 breakout boards, keeping in mind this is about a $5 chip. I had to buy some $25 breakout boards that had that chip on it, just so that we could use some hot air to pull it off and stick them on our tracker boards. But before all that happened, we needed a way to be able to work with these things, because you don't have the luxury like you do with through hole components of, you know, being able to jam these things in a breadboard. Thank you. I was looking for the word. So we ended up having to get familiar with schematic and PCB drawing programs, get familiar with that, get comfortable with that, and then design our own breakout boards so we'd have a starting point. And that's what this is pictured here, was one of our first breakout boards to be able to utilize these components and shove them into a breadboard, because at least we had on on the left-hand side, you can see a normal size pin header that could be able to be plugged into the breadboard. Let's see. Well, oh, this is a good one. Perspective. So these components are the smallest ones that we have to work with. They aren't the smallest ones made. There is that 0402 that you see there, the one up, that's a capacitor. It's up by Lincoln's eyeballs. That capacitor, the 0402 means that it's 40 thousandths by 20 thousandths of an inch in length and width. The 0603s, after you've worked with those 0402s for a little while, the 0603s seems kind of big. Raj and I have decided that future designs, we will no longer use the 0402s if we don't have to, because they're too damn small. And for, you know, guys in their 60s that, you know, you need more light, you need better glasses. It's like, this may not have been the optimum time to get into this hobby, but hey, we're having fun with it. Thankfully, there's tools that are available to help us out with that. So we started working on this transmitter, and with this next slide, I think I'll let Raj kind of explain what we went up against after that.
Okay, well, as Raj kind of alluded to, this tracker board that he showed back in that other picture there has a 32-bit CPU on it. We've got GPS. We have the radio system. We have temperature, barometric pressure sensing. We had a buck boost switching power supply so that we could work off of a wide range of solar cell voltages. And there's a super cap on there that we use to store some energy. It turns out that it wasn't, as Raj said, it wasn't practical for us to store enough energy to be able to have the thing run overnight. And even the weight of the super caps was an issue for us. And so the super cap will run a couple, 2 or 3 minutes probably if you went from no sunlight or from sunlight to no sunlight. And it's more than enough to ride through clouds and things like that, particularly with the buck boost regulator. But then the transmitter shuts down whenever it gets dark, and it doesn't start up till the next day. Raj talked about the libraries. We used a lot of other people's code, and God bless them for doing that, because to start something like that from scratch would have been just completely overwhelming. However, even if you've got a library of code, and some of these libraries, there's one library we used that had 17,000 lines of code in it. And so even though somebody else did the work for you, you still have to at least have a reasonable understanding of how the code's working and what functions you need to call to do the things that you need to do. So we needed to, you know, understand all of these programs. And unfortunately, some of the guys don't comment their code real well. And so I spent many, many, many hours dissecting code and trying to figure out what was going on. So anyway, a couple of slides that we have here, the AFSK, if you're not familiar with it, is a tone encoding that was basically very similar to what our 1200 baud dial-up modems used to be. And it works on 12 and 2200 hertz tones, being binary ones and zeros. And we had started out using trying to use the Arduino, what would be a typical Arduino Uno processor, which was an Atmel 328P. And it's an 8-bit processor that runs at 8 megahertz. And we started doing some testing on it and found that by the time we got done, and a lot of the stuff that we're doing here is interrupt driven, because it has to be done on a particular time basis. And so we did some analyzing and found out that this 328P CPU was going to spend almost all of its time inside interrupt routines and wasn't going to have much time for anything else. So we ended up going to it was another Atmel product, but it's based on a ARM Cortex processor, a SAM D21. And we went from an 8 megahertz to a 48 megahertz machine, from 8-bit to 32-bit. 16 times as much program memory and 8 times as much RAM. It also had more I/O, and it actually had a dedicated actual D-to-A converter on a chip, as opposed to using pulse width modulation, which you would have to do on the other chip. And so we decided to use that D-to-A converter. Some of the pitfalls of that is the libraries that we had were written for the 328p, and there was some low-level programming there that interface timers and interrupt handlers and stuff like that. And all the hardware on the SAMD21 is completely different, and so we had to rewrite those routines to be able to support those the low-level stuff, and that was pretty involved too. But making sure that we had the timers working, and power management was another thing. So we spent a lot of time on that. And Raj, if you want to go to the next one there, on the left there, you're seeing an actual capture that we did of the APRS operating. And obviously you can see the higher frequency and the low frequency and the transition between the two. And this was the output of the D-to-A converter. And so you can see it kind of was a stepwise thing. We ended up using we were able to get a 65 or 62.5 kilohertz sampling rate. And so you can see that we had quite a number of samples there per wavelength. And once we ran it through a low pass audio filter, we got some really nice clean audio out of it. One of the other things that we ran into that there's pre-emphasis on this, and you can see that the 1200 hertz signal has been attenuated with respect to the 2200 hertz. In the digital domain, and as you guys might know with pre-emphasis, a lot of times there's a gain block in there that boosts the high frequencies. But when you're working in a digital domain, you've got a limited pool that you can draw from as far as output voltages. And so we basically attenuated to 1200 hertz, but it's a relative thing. But it also turns out that it was not contiguous when we do this pre-emphasis. And so we ended up having to go back in and modify the code and kind of skew from one frequency to the other so that we didn't have these big jumps that would be high frequency harmonics. We also employed a 7-pole Chebyshev harmonic RF filter, and that was a new, it's like everything we did, we had to stop and get out reference books and read about, how does these filters work? How does pre-emphasis work? How does anything work? The manual for the SAMD processors like 750 pages long, and you got to go through that thing and figure out what's going on. And so we spent a lot of time doing things like that, but it worked. And so Raj, if you want to go to the next slide.
Sure.
Another thing that we ran into was that as you traversed the Earth and went to different areas, the radio frequencies changed. And so we had to use the GPS coordinates to detect where we were at and then reprogram the radio to work on different frequencies. There's also some areas, there's certain countries that do not want anybody transmitting over their airspace. And so we also had to detect those areas and have no transmit zones. And so Raj spent quite a bit of time working on a routine. It was called a point and polygon, which again was some routines that somebody else had developed. And we basically adapted them to our program so that we could tell where we were at and be able to do the switch the radio frequencies. And so it turns out that Roger and I had some unique but also overlapping abilities. And so we just kind of took pieces of the pie and attacked them, and maybe came back a week later and said, hey, I got some code here for you to look at. I think this is working. And that worked out really well for us. These were the point and polygon routines. Basically, you would define some corners with GPS coordinates where you're at. And you can see there that for there were a few places that we didn't figure we were ever going to have a balloon fly over, so we weren't concerned about them. But this was some of the research that we had to do. in order to get all this stuff in place. And then you can see he's got a map here that kind of shows all the different locations that that the balloon would be detecting.
Yeah, and it helps to have a friend that's retired and has the same goals in the hobby as you do, and spends a lot of his waking hours pouring through Google sites or Google web searches and sites, and reading through all the muck and trying to find the good stuff that's in there. Raj did a phenomenal job of getting us over some of the rough spots. You want to talk about version 1 or?
Yeah, sure, I can. When we started developing this, this was one of the situations where we had the chip shortage, and we actually wanted to buy some of these CPUs and DigiKey, Mouser Electronics, nobody had any. And so we ended up designing the board to take an Arduino Uno, and I'm sorry, this is a SAMD.
Mm-hmm.
And yeah, because we started out with the Uno and couldn't get it to work. But anyway, this worked pretty well. At least we got it up and running. We could get it to do some things, but we immediately found out that we had omitted some components that we desperately needed, and that we also wanted to add some things. We wanted to measure the battery voltage with analog input. We forgot to put the sensing on for that. It turns out that our switching power supply was only rated absolute maximum rating on it was 5.5 volts, and our open circuit voltage on our solar cells actually went higher than what the spec sheet said, and it was going to cause some damage. So we ended up having to put a Zener diode on there to basically swamp that out and protect it. And so we ended up with a few modifications. Another thing that we tried to work on, once we got this running, it was drawing about 70 milliamps at maybe 4.5 volts. And the major components, the CPU had some pretty good capabilities for doing power management, as did the GPS. And the radio, the quiescent current on it was probably about 15 milliamps. So that was pretty significant as well. And so we started thinking about ways that we could get some power management. And so we started, we got a hold of some solid state load switches, and that's a little device with all the wires hanging on it there. And we powered the radio down when we weren't using it. And then we would power it back up again. We said, okay, if this works, then we'll go ahead and incorporate it into the next design, which is what we did.
There was one step in between.
All right. And so when we started powering the radio down, when we'd power it back up again, we had some really odd behavior going on the tracker. And I'll be kind of brief about it, but this radio chip has 8 outputs on it that are individually programmable, and we're only using one of them. And the manufacturer put pairs of radio outputs with a separate power input so that you could selectively run them off of different voltages. If you had it in a circuit board and you needed 3.3 volts and 1.6 volts and things like that, you could power them off of different things. And the quiescent current on each one of those inputs was about 1.5 milliamps. And so we just opted to not power up the inputs or the outputs that we weren't using, thinking, why would it be a problem not to power the outputs? Okay, it's not like you're leaving an input unpowered. These were outputs. And anyway, what we found was happening is when we would power this chip down, it uses I2C for communication. And so the I2C bus was still active. And there was evidently some kind of a latch up condition that was working in there, because when you'd power the chip back up again, then the chip would slam our I2C bus down to ground and basically kill the communications and basically kill the board. And the only way you could get it back was to cycle power. And so we had to find some way to prove that. And what was interesting is that when we tried to do this on the breakout boards, we couldn't duplicate the behavior. And so I ended up taking a very small soldering tip stuck it in a metal lathe that I have, drilled a tiny little hole, stuck an even tinier wire in there, and used that as a tip for a soldering iron to put this 38 gauge magnet wire on there so that we could power up the other inputs on the chip. And once we did that, our latch up condition with the I2C completely went away. And so then when we, and here's some advice. If you're designing something like this, if it says on the manufacturer's data sheet that you should do a particular thing, then you should do that. And if you read the fine print in there, they said that these inputs, all these power input pins should be powered up. And they didn't really say why, but it turns out that there's definitely a reason. And there were a lot of headaches trying to figure out what was happening here and how to get it fixed. But anyway, when we did the next version of this, then we made sure that those were all powered up. And since we were using a load switch to power the entire radio down, as long as all those inputs got powered down together and powered back up together, then we didn't have any latch up problems, and it worked as we expected. And we were able to get our power consumption from average of about 70 milliamps down to about less than 10. So we got a 1 in 7 improvement in power consumption. Still isn't enough to keep it running overnight, but it still helped a lot, particularly when this thing is first powering up in low light conditions. The GPS needs to use a little more power, and so it was good to be able to conserve as much power as we could to so it would get started up as quickly as possible. So there you go.
Yeah. So after we discovered what the problem actually was, thanks to Raj's meticulous tiny soldering, we got together and designed board number 2. And it was like, all right, we're going to incorporate all the problems that we have. We're going to put those solutions in play. This is going to be the guy, and Raj even came up with an idea because he had spent so much time trying to get scope probes and meter probes in different places on these tiny components. He goes, it'd be nice if we had some test pads, that we could, some big test pads so that you can get your meter probe on them and that kind of thing. And then from that idea, this whole idea of putting a little header on there and a little bit of ribbon cable and bringing some sizable test points out that were labeled from some of the major places, after the audio filter, the GPS receive, all the important points that we thought would be the guys. We decided to bring those out on that header. And I have to tell you, that was a really good idea, because that's saved us on a few things here.
I was going to interject real quickly, Raj. One other reason we did that too is we talked about just having test points on the board and having some pins sticking up. But when you're transmitting RF and you've got these pins sticking up, then it just injects noise into the board. And so that's why we decided to go with the external header. And besides that, we had a little better spacing, because you got to have something you can hang a scope probe on, because even if you got a test point, you can see there's still a couple on the board for the crystal there, but it's still a pain if you're trying to capture something with your oscilloscope and you have to hold the probe on there. And so by having this test header or test board off there, it was very handy for trying to figure things out when we needed to do some testing. So over to you.
All right. So we were just fixed on this board. It's like, this is going to solve all of our problems. And the boards came and we started doing testing. And Raj called me one night and said, "Hey, are you having any issues getting a GPS fix?" And it's like, well, we have a couple different scenarios here. His office and workspace where his computer is on the main floor, and he has a big window in his office. So he's usually able to have the tracker mounted on a little stand and be able to get a GPS fix in, I don't know, what was it, Raj, 15, 20 minutes?
Yeah, something like that.
And of course, my workspace is in the basement and it's pretty hard to get GPS signals, through a couple floors of the house. So typically, if I wanted to do any testing, I had to go out on my back deck and wait 10 minutes to get a GPS fix before everything came to life. Well, we started discussing this and it's like, this just, we changed the antenna. The GPS antenna is the little white rectangle that you see on the top of this board. It's a ceramic antenna that seemed to be working really well on the first generation, but on these, we brought the rest of the board up because we needed a little bit more real estate to put some of the components on. But because the manufacturer says, it needs to be clear, like no copper traces or anything in between the layers for a certain area, it's like we thought, well, this is the same thing, just a little different. Well, after trying to figure out what the problem may be and if it was the antenna, there's a little blurb in the data sheet that said, as you can read here, it's like, hey, if you need help laying out your antenna, send us your Gerber files. So once again, we were having lunch one day and we started discussing, it's like, maybe it'd be worth just sending our design to them and let them see. It doesn't cost anything. And so Raj got all the appropriate Gerber files and emailed Johansson Technology, and this was the reply. Hello, Roger. This is not going to work. The antenna must be on the edge of a printed circuit board with no perpendicular ground. See data sheet. Well, it was kind of like back to the drawing board again. We've thought, and you got to keep in mind, every time that we have one of these boards, we design one of these, we have a session where we're drawing the schematic. We have a session where we're laying the board out in the CAD program. And then we shuffle all this stuff off to the board manufacturer. And it's usually about 2 weeks before we finally get something back that we can solder up and play with. So the ultimate goal with this was to try to get a balloon launch before the end of summer. That didn't happen. It was a good goal to have, but we didn't quite make it. So with the help of our fine friends at Johansson Technology, we were able to redesign the board, and then we sent them the latest version of board number 3. And I believe it was the response was something like much better.
Much better. Yeah.
Well, and I got to tell you, Raj is able to get a fix, a GPS fix or a 3-dimensional fix on his desk in his office now in what?
Couple minutes. Yeah. Yeah. It's a huge improvement. And in our defense, when we designed that second board, by looking at the manufacturers, and here's a caveat, when we actually, and I have to say Johansson was really good about, the engineer actually took time and talked to us on the phone, and he explained that, because there were some photographs or there were some pictures in their documentation that showed something similar to what we had, and his response to that is, well, we're kind of showing what some of the orientations you could use for the antenna, but it's actually specific to the antenna that you're using, whether you would do it like that. And we thought that we had designed enough, I guess, call it like a keep out area or something around the antenna, that it would be able to pick its signals up. But it turns out with those ground planes that are perpendicular to it, that we changed it from an omnidirectional antenna to kind of like a dipole or something. It's there's a lot about antennas I don't understand. And so at any rate, when we did this, it worked much better. So I mean, there was no question that our design was faulty and that it needed to be changed.
But fortunately, what we did fixed it thanks to their help. This next slide is like, this isn't a plug for this company. But if you guys are doing any kind of circuit board prototyping, these guys do really good work and it's cheap. I don't like supporting our Chinese friends, but gosh darn it, they make it hard not to. You can get 100 by 100 millimeter board up to that size. You can get 5 boards for $2, and that's that's the price for the 5 boards. It's not $2 a piece. It's $2 for 5 boards that size.
And that
You
was
go with the,
that's a 2-layer board, right, Raj?
yeah, that's a 2-layer board.
Right.
But the 4-layer boards that we went to, I don't think they're that much more. I
It
want
was
to
like
say,
$7 or something like that, wasn't it? For 5
yep,
of them?
yeah.
Yeah.
If you use the economy shipping, you can get it, like I said, in a couple of weeks. Shipping will cost you, on probably another $10 or so. We have not had any manufacturing, what do I want to say, problems with the boards. They've all been extremely good quality. It's just hard not to use these guys. I early on, I used some, before I started this project, I was using some folks in Colorado because, they're made in the States here, but they're about, I don't know, 2 to 3 times this, and the time and the turnaround isn't any better. So I can't tell you where to shop, but I got to put a plug in for these guys just because they've worked well for us. So 3rd time charm, we get our new boards. As always, some assembly required. We lay out the bill of material. We put components in individual compartments, and they're indexed so that we get the right component in the right place. And so far, other than somebody putting some chips in upside down, that would be me, and and some inductors upside down. Who knew? I could see the little coil. I didn't know that was supposed to go down. Anyway, this stuff's tiny, guys, so cut me some slack. We got the boards assembled. We did some testing. We overcame one little hiccup. So we decided, hey, maybe we should start prepping for a flight because, it's getting cold. It's getting to be winter time, and that changes the way the wind patterns are. And this may not be the optimum time of year to do this. So what do? Well, you got to buy some balloons. I bought the balloons probably 6 months ago. These are Japanese Yokohama balloons. They're a high quality Mylar. The silver coating isn't on these. The silver coating also presents extra weight, and everything about this project is weight. I mean, if you're not talking about component size and power management because it's solar powered, it's like the next thing is weight. The balloons, according to the Pico balloon community, you gotta stretch them and leak check them. And well, why do you stretch them on the ground? It's like, well, if you don't stretch them on the ground, they're going to stretch in the air, and you're going to sacrifice altitude because of it. So we went over to Raj's shop. We pumped it full of compressed air to a whopping 0.35 psi, and we sealed it off and let it sit overnight. And the next day he went out there, and I think it was like 0.348 or yeah.
Yeah, it was no leaks.
Yeah, no leaks. So we decided to let it sit for a little bit. Well, then I started talking to my favorite meteorologist, Mark Connor, and they're in Omaha, and we started looking for some times when the winds were going to be calm. Well, of course, they were screaming last Friday night, but Saturday morning at sunrise, it was going to be nice and calm. So we decided to quickly get together Friday night, completely evacuate the balloon thanks to a little vacuum pump that Rod uses for woodworking, and pulled all the air out of it. We charged it with the right amount of hydrogen, or at least we hoped that we did. You want 6.5 grams of free lift. So that means you got a balloon that weighs like 41 grams. The tracker weighs 17.5 grams. The tape and the string weighed like 0.8 grams. This all needs to be taken into account. And then the difference is you want 6.5 grams more, so that's what takes your balloon up. So last Saturday morning, when it was 9 degrees out, Raj and I went out to the local practice field for the high school, and we launched number one. Now, I got to say, this is one of those things that's quite a bit different from the latex balloon flights that I used to do, because there was all the prep, there was the filling, there was the checking out of the radios, making sure that the APRS was being received, you know, and all this kind of stuff. We went out there, we had it plugged into a power supply so we could still make sure that it was functioning, but essentially we were launching a dead tracker into the air, and we knew that it was going to be an hour or two before the the super cap would be charged enough to fire everything up. So we launched the balloon and we watched it sail away. We chatted for a little bit with a couple friends that came out, and then we went home to warm up and wait. As you can see from this picture, we made it from Grand Island clear down to the southern part of Virginia. The winds were just screaming that day up at 40,000 feet. We accomplished a number of things that day. I mean, if we never hear from this balloon again, we at least accomplished several of the goals that we set out to do. And that is, we made a radio that can actually, a transmitter that can actually be received by various APRS stations. We found out that it powers up nicely after it gets, the supercapacitor gets charged. We had the right amount of gas in, because this thing went up a nice slow, about the ascent was probably 1 meter a second. We climbed up to 40,000 feet and leveled off and started to float at 40,000 feet. And that's really the sweet spot in the jet stream that we wanted to be at. Now, the reason that the little trail ends there on the map is because that was about 3:15 in the afternoon here. The sun angle's pretty low this time of year. It's out on the East Coast, and the old sun was creeping down. The shadow was creeping over the solar panels, and it tucked itself in and went to bed. I'm sure that by the time we went to bed that night, it was somewhere out over the Atlantic, if it was still floating. We have not heard from it since, and we are not surprised. These are the winds up there as of tonight. It's kind of hard to see, but you can see shadows of the United States, and then making its way over to Africa. With a little luck, we should be over African soil now, if it's still floating. I always preface all of my statements when I'm talking to folks at work about this and other people. It's like, if it's still floating, and we hope that it is in the air, not in the water. So those are the winds, and the dark spots that you see there, you can kind of see from the legend on the right that you're talking about, 90-mile-an-hour winds. Saturday afternoon, we have position reports and speed reports. That thing was doing anywhere from 160 to 180 miles an hour. The jet stream was moving us across the country.
Comment.
Now, go ahead.
Yeah. Do you have to deal with the FAA when you're launching these?
Good question. The short answer is no, and I'll clarify that. Even back when we were doing the weather balloon or the latex balloon flights, there is a specific federal aviation regulation that governs untethered balloons, and as long as you keep the payload below a certain weight, and shockingly enough, that's 6 pounds, and no total payload under one balloon more than 12, it's like you have permission to launch it whenever you want, wherever you want, without telling anyone. On the flip side of that, when I was doing the latex balloons, I tried to either call flight service, or if I was close to Grand Island, I would call the tower so that they could issue a NOTAM. And one of the last flights that I did, I usually monitored some of the airline traffic while we were, chasing the balloon. I actually heard one of the airlines that said that they wanted to deviate to the south because of the weather balloon NOTAM. So, the system works. to my knowledge, no one's ever had an incursion as far as, any incidents with a weather balloon and an aircraft. The National Weather Service launches, 90 balloons twice a day from different locations across the country. So these little guys, they fall under that same thing. It's like, now I can't say that for other countries because I don't know their regulations, but I just know that many others from all around the globe are doing this. Now, the first person that ever got one of these little Pico balloons to circumnavigate the globe was a guy from the United Kingdom. That happened, I want to say, about 10 years ago. He also has the record for the most trips around, and the record for the longest duration. He had a balloon up for over 700 and some days, and it made 27 trips around the globe. I'm not looking to beat that goal. I don't think Raj is either, but we'd certainly like to make at least one trip just to say we did it. Now,
I'd say we'd be happy just to hear from it again at this point.
yeah, exactly. And that will hopefully come a little later this week.
And I want to make one other comment too. You mentioned that you don't know what other countries do as far as their regulations. And we can just say that we hope they don't have extradition treaties with the United States if that's the case.
Exactly. Thanks to our good friends at the National Oceanic and Atmospheric Association, this is a tool that is available to you, me, and anybody that can access the internet. This is a high split model. I believe it was devised many years ago for plotting trajectories for radioactive fallout, some of those kinds of things. It comes in really handy for Pico balloons that are floating at 40,000 feet. So if you put in the right parameters, you can spit out a 10-day forecast. And I did this one just before we got together tonight. The pressures that you're seeing down there equate to about the 12,000 meter or the 40,000 foot mark. Okay, the blue one would be if we still were right at the 40,500 feet that we were at the last time we heard from it. The big circles on the plot are every 24 hours, and then the smaller icons are every 12 hours. So that first one that you see right off the coast, off the East Coast of the United States, would have been Saturday night. So the next one, 24 hours later, Sunday night would have put us over the Atlantic. And then Monday night, we should have been, let's see, Saturday, Sunday, Monday should have put us close to the coast of Africa. And tonight we should have been over land, but of course it was dark there by early afternoon here in the United States.
And desert.
Yeah. Well, and as you see the little pink arrow, that's where I'm guessing we should be if we're still floating and this forecast is accurate. That's about where the balloon should be right now as we conclude this little presentation. So there's not a lot of APRS ground stations in the desert. There's not a lot of APRS ground stations in some of those areas over there. However, our saving grace may be Israel and definitely China if we fly over mainland China. So if we don't hear from it tomorrow, if it's still up there, we should hopefully hear from it before the end of the week. So other than that, we have managed to meet several of our goals. We still have some more to go, but I got to tell you guys, this has been a lot of fun. We've had a riot, and I don't know if Raj has got anything else to add, but I'd say we can open it up if you have any questions.
Yeah, I don't have anything else to add, and hopefully you guys aren't falling asleep by now, but certainly if you got any questions, we'd be happy to answer them.
Roger, you're doing your tracking through APRS?
Yes. There are two specific sites, and the one that you see on the slide right now, that amateur.sondhub.org. If you punch in the slash my call sign -11 and make sure that's capitalized, otherwise it won't take it. You're not going to see anything tonight because it's been more than 3 days and it won't even show you that last position. But if it were to rear its ugly head, so to speak, you'll be able to see it on that. There is another extremely popular APRS site that I used to use all the time before this one came about, and that is aprs.fi, or Foxtrot India. It's a Finnish site, so hence the website name, the .fi. aprs.fi, and you can do a search for my my call sign and the SSID, which is the -11. Sometime in the very near future, I'm guessing we'll be launching the other tracker we have built up, and that'll be flying under Raj's call sign. And I try to post on a there it is, waiting to go. I try to do regular blog posts. Sometimes I get a little busy with the project itself and not documenting it. But if you see that that rajasramblings.wordpress.com, I did one Saturday, or I'm sorry, Sunday, that kind of, it was sort of a wrap up of the last couple of weeks. A lot of the pictures you saw tonight are in that as well. But I try to keep that up, and then one of these days I'm going to try to do a YouTube video on everything that we've been doing the last 8 to 10 months in the project.
Is this presentation on YouTube?
No, it is not, but I noticed that somebody was recording it.
I was, yeah.
Ah, okay. All right. Yeah, certainly welcome to put it anywhere you'd like. You know, if you want it on YouTube, you're welcome to post it there. If nobody has the means for that, I'd certainly be glad to post it there myself. So
yeah, I've got the means to do it. Some of the guys couldn't make it to the meeting tonight, and
sure,
wanted to see it.
Okay, yeah. Rich Albright was the first one that hit me up about this, and I had I thought the name sounded familiar. He helped me out at work when he was working for Bar Thorpe. I bought some HMI equipment from him to replace one of our failed ones at the power plant. So Rich was the first one that contacted me about possibly doing a presentation. And I was like, I don't really do presentations.
Yeah, he was the one that's missing tonight that wanted to see it.
Yeah. Well, I'm glad that I'm glad you recorded it so we can listen to me babble on and have Raj make some sense out of all this. So, anybody got anything else?
I got a question on your weight there. You know, you said you had a ½ an ounce. Is your current transmitter, is it at the ½ an ounce weight, or did that change at all with all these versions you've got?
The current transmitter is 17.5 grams. That includes the dipole antenna, which is if any of you are guitar players, it's an Ernie Ball number 13. Not my idea. Yeah, there you go, fellow guitar player. That includes solar panels, antenna, supercapacitor. That is the entire weight of what goes up, not including the string and the tape. We had 10 foot of fishing line and about 6 inches of Kapton tape that we all meticulously weighed. And it paid off. Either that or we got extremely lucky because it floated where the calculations said it should float. So it was like, yes.
And we were pretty careful about, and I don't know if you saw there that we had a milligram scale and had 100 gram weight. And then we tied the balloon onto that. And then of course we would measure the lift because it would subtract the weight off of it. And so we had the calculator out there and weighed all of this stuff and figured out what we needed to do. And then we'd have to, and of course, when you got this little tube, 4 millimeter tube that you have to stick up inside the balloon to get the hydrogen in there, then of course it's got weight as well. And so to be really sure, then we'd have to pull it out, weigh the balloon or see how much lift it had. Oh, we got a little bit too much. And then we stuck the vacuum pump on it and pulled out too much. And so then we had to keep putting it in, but we got it. I think we ended up like 6.48 and we wanted 6.5 grams. So, I mean, it was really close.
Yeah. And it, honestly, you saw the balloon, when it's got the hydrogen in it, it looks like a sick deflated balloon. It looks like, well, that's not going to fly. But, you know, once it gets to altitude, it's fully blown up, if you will. It fully expanded, and according to all the calculations, it should be under about 0.22 psi of pressure pushing out to be able to float where it's at with that weight. So it's been a deal. It's been fun. It's been challenging. It's been frustrating. It's
Thanks to the support of viewers, you can always count on your browser.
I noted you said hydrogen.
Tons of stories
yes.
you can't
Yes.
find anywhere else. Now is
We used hydrogen for two reasons. One, hydrogen has twice the lift that helium does. And the weight is so precious here that we needed that. And hydrogen is also cheaper than helium and available. We couldn't even get helium. And honestly, you know, we worked in power plants, and power plants have generators that have 30 psi hydrogen in them. And so we've worked around it, know the safety procedures and stuff like that. We pulled a vacuum on this balloon before we started putting helium or hydrogen in it. So, you know, there was basically, it's not explosive as long as it doesn't have air in it. And, you know, the first thing you think is you see pictures of the Hindenburg going down. But honestly, for a 3-foot diameter balloon that was full of hydrogen, even if it got a leak, it would just go puff and it would be all done. It wouldn't be a big deal anyway. But we were very comfortable, careful, but comfortable when we were filling it, and it worked exactly the way we needed to. And honestly, I don't know, we can probably fill 20 balloons off of this little hydrogen tank that we got, because it doesn't take very much.
Yeah, I think we got about right around 2 cubic feet of gas in this thing.
Got a question.
Sure.
Just curious, when you were doing the latex balloons, the way those launches went, did those just continue to lift until they stretched out and broke and came back down?
Those particular balloons are made to shred. I guess it was probably a design for the Weather Service. I'm not sure, but yeah, we put enough helium at that time in those so that we could achieve like 1,000 feet a minute ascent rate, much like the Weather Service does. And that would get us, you know, about 90 minutes to burst. And then once it burst, then a parachute was tied to the bottom of the balloon and it came down on the parachute.
Yeah,
usually
I
not.
made
Go ahead.
note of your I think 6.5 grams of lift with these. That's probably to kind of regulate that, so these don't do that, right?
Yeah, these are about, oh gosh, I think it was like a meter a second. I want to say it was 150, 200 feet a minute, something like that.
Yeah.
It was a slow climb, but it was steady.
Sure. Yeah, it's very, very interesting. I've not seen this before with these that can go 27 days and that kind of thing. When the kids were in high school, I had thought about doing the latex thing, you know, just launch it from the high school and go pick it up in Woodbine or something, you know.
Sure,
But
sure.
yeah, to see this launching it the way you guys did, and you suspect it's over Africa now, that's really neat. Thanks for the presentation, guys.
Hey,
You're
you're quite
welcome.
welcome. It was fun.
Oh, I also made note of your jlcpcb.com. I've messed around with the Arduinos quite a bit and made
Okay.
some of my own circuit boards. But if you're familiar with the Arduino, you're probably familiar with fritzing. And I paid $50 to get just a Arduino Shield size circuit board. So yeah, $2 for 5 boards, 100 by 100. That's remarkable.
It's hard to be. I came across this site. We had an intern working for us at the power plant a couple of years ago that was into making his own circuit boards, and he told me about it, and I was like, "You got to be kidding me, really?" I said,
Yeah, that's
"Are they
crazy.
junk?" He goes, "No, they're good quality boards." Okay.
Cool.
I-
Yep.
One
Thank you very
comment
much.
I could make, one comment I'd like to make too. One of the things that amazed me about this entire project is that we've got access to so much technology. When I graduated from engineering school, a program to do printed circuit board layout was probably $5,000, right? And we use KiCad and it's free. And it used to be you'd get a double-sided printed circuit board made, and it was $100 if to get a production lot of them. And now we can get them made for 50 cents a piece, and being able to do 4-layer boards and 6-layer boards, and you start looking at the Arduino, the development environment and all of it's just amazing the number of sketches and libraries and things that are out there. And pretty much somebody's done something. Like I said, God bless them for doing all that work. There's no way that we could have done this from scratch. At least not. It would have taken us years to figure out how all of this stuff worked. And so it's just amazing to me that we even had the abilities to be able to do this. And it's really fun. It was still a lot of work, but it's doable.
Yeah.
And it was also, relatively inexpensive. I think Raj figured out that he figures we maybe have $90 into one of these to the entire tracker thing. And I'll tell you, it's well worth it from a fun standpoint. And we're going to wait and see where this other balloon, we're just hoping ET is going to phone home one of these times here pretty soon. And as soon as we see what happens to it, we're going to launch another one.
And when you
Another
make a
question.
$100 donation,
Yeah.
Yeah.
Go ahead.
What's the power output of the transmitter?
This program.
And what's the range of the transmitter?
Oh, okay. We're swinging. It's a little hard to tell because we've got our oscilloscopes aren't capable of accurately measuring it without doing some calculations and stuff. But I figure we're probably somewhere between 100 to 25 milliwatts. We're swinging a 3.3 volt signal into a 50 ohm load, and that's 3.3 volts peak to peak. And then we've got this RF filter on the output of it, and there's a little bit of loss there, and who knows how much we have. But when you measure with a scope, of course, then you got some attenuation there because the frequencies are so high. So I'm going to say 50 milliwatts or less. And one of the things that proved right away is once we got up in the air, we had stations all over the United States that were, within our range. Let's say maybe 15, 20 miles or something like that radius as the balloon is moving along, Raj.
I think its footprint is probably about 100 or a little over, but the further you are from the station, the less chance you have of getting through if there's a more powerful one, because he with the most signal wins, and
But
we're
we
kind
got
of
hits the whole trail along. So and then what was your other question? Was it the range of the transmitter? Are you talking about frequency range or
Distance range, you already mentioned that.
okay, all right,
Okay.
good.
The footprint. Yeah.
If it does pop back up on our on the amateur.sonhub.org site, by default, I think it shows you a circle of where it can be received based on that altitude. So you can watch for that and kind of get an idea. I wanted to add one more thing, and I actually meant to put this in the presentation. Another ham from the East Coast back during the COVID times did a nice little online Zoom session for us. And he showed us how he does surface mount component work. And Raj and I kind of, joined into the Zoom session to watch him assemble one of his trackers. He was doing the Pico balloon stuff. And it was like, okay, this is doable. And what we ended up doing was, we made a reflow oven. It's a toaster oven with a controller on it. I mean,
Black and Decker. Yeah.
yeah, Black and Decker toaster oven. Crank the knobs all up on high, and it's tied to an on-off or a set point controller that I bought through Adafruit. Made some curve changes on it for the type of solder paste that we were using, and we if you walk around my my office down here much, you'll see a lot of these little blue boxes. JLC PCB also does, I sound like a marketing person for them. They'll also make the stainless steel stencils for you, so that we don't hand solder all this surface mount stuff. We could, but I think we'd probably be crazy by the time that we got done with the first board. You put the stencil over, you smear the paste on, you peel off the stencil, and now you've got the paste on all the little pads based on your design. And then you place all the components. Don't bump
With a
them
microscope.
with a microscope.
Yeah.
There's some pretty reasonable stuff on Amazon. We've got one, you can get them down as low as $25. I got one with an LCD screen for $250. Yeah, right there. Game changer. Because you're not going to spend the whole night like this, with one of these guys. Anyway, this reflow oven, it's like we get all the components on there. Don't bump them, okay? Because then it makes more work. The last time I bumped the USB connector, knocked the capacitor off, got it out of the oven and went, where the hell did that capacitor go? And it was like stuck up against the USB connector, and the spot where it was supposed to be was empty. So anyway, and that was one of those little, one of those small ones that Lincoln was eyeballing earlier. Anyway, run it through the reflow oven. More often than not, we don't have to do much rework at all. You may have to go in and touch it up a little bit with an iron, but gosh, it makes the surface mount work doable. So even for us older guys.
Yeah.
Anything else?
I know, I guess I could say if we can do it, you guys can too. Like I said, it was a lot of work, but it was fun. It was extremely interesting. We learned a ton of stuff. We're still learning things. And there's a lot of things that I never thought that we would be able to do. And it turns out that we can. And so highly recommended.
Another question.
Yes, sir.
Did you think about using any off-the-shelf GPS units and transmitters for the GPS? I tinker with RC airplanes, drones and so forth. Yeah, he's shaking his head. You know what I mean?
Yeah. I think Raj will probably concur, but I think the biggest reason that we didn't is weight. As far as Pico trackers go, ours is probably the heavy guy of the bunch. Trying to get all this stuff jammed on a board and keep it under that weight limit of, trying to keep the whole thing under an ounce. And some of these guys are doing it on a freaking postage stamp size board, with even lighter solar panels. And it's like, guys.
I don't know if you can see this, but if I can find the camera, that is a camera and a 5.6 gig transmitter. Transmits video.
Yeah,
that's what I was querying about.
Yeah. It's hard for me to tell from looking at it, but I'd be curious to know what that assembly weighs. Just curious.
Okay, I'm looking.
Okay.
I guess to answer your question too, part of it is you know, and you bring up there, you know, it would have been very practical to do something like that if you could, but it was also kind of fun designing this board and
Yeah,
putting the components on it and making it all work and, you know, writing a program and all that kind of stuff for it. And so that was part of the challenge as well.
Yeah.
But sometimes too, it doesn't make any sense to reinvent the wheel and you know, there could definitely be a trade-off there for sure.
Yeah. When we got started, it was kind of like, well, we're going to come up with our own code, you know, right from the bottom up. And after we got into it a little ways, you know, we started talking. It's like, well, you know, it might not hurt to use some of this other stuff that's available because, damn, this is hard.
4.7 grams.
Okay. So, you know, it's certainly a possibility. Depending on its power requirements, something like that could go up.
It's single lithium polymer cell. So what is that, around 3.5 volts thereabouts, 3.7 volts thereabouts?
Yeah.
Well, you guys are cool, I'll tell you.
Well,
All right, Larry, we're gonna have to design one of those and use that video you got there and put that rascal up so it can give us some video across the United States and wherever it goes, transmits back.
there you go.
Yep. Get a partner or a group and start working on something.
This has been way more fun doing it with someone, and especially a good friend that,
Yep.
like I said, has some of the same goals. We've had a riot. So
Yep.
if you guys have any other questions after we dismiss here, so to speak, my email is my call sign at gmail.com. Feel free to, if you have any questions for me or Raj, I'll certainly pass things along. Yeah, we're here to share.
What's the calls again? Or could you show them to us?
Yeah, it should be on the screen, but it's a Kilo Charlie 0 Mike Whiskey Mike.
So does your Pico board transmit your
Triple
call
mic.
sign every 10 minutes?
Actually, it transmits our call sign every minute. With every packet that goes out, every transmission, it has the call sign on it. So, yep, we are complying.
Good APRS going on there.
Yeah.
Well, we have kept you for 90 minutes of wonderful time here. Thank you guys, Roger and Roger, for